Hello friends, I welcome you in lecture number 2 on chi-square distribution. We have seen what is chi-square distribution and how its probability density function is defined in lecture number 1 on chi-square distribution. If you have not seen lecture number 1 on chi-square distribution, then I suggest you to watch that lecture first and then go for this lecture. In this lecture, we will discuss how to use chi-square table. So for that we recall that if we consider this density curve of chi-square distribution with some new degrees of freedom, then the point on the horizontal axis denoted by chi-square alpha is the point such that area to the right side of this point is equal to alpha. In other words, chi-square alpha is the point on the horizontal axis such that probability that chi-square is greater than chi-square alpha is equal to alpha. So in the chi-square table, we will be having this type of situation. On the left column, we will be given degrees of freedom, and these column headings will be alpha area in the tail. So these column headings are nothing but area alpha which is in this tail. So we have to decide the chi-square critical value corresponding to given degree of freedom and given area. So remember, these values in the table are nothing but chi-square critical values. These points are in the table such that area to the right side of this point is equal to alpha. So here I have this chi-square distribution table, and here you can see the left column corresponds to degrees of freedom which we denote by nu, and these column headings are area to the right of critical value which we denote by alpha. So we have different values of alpha here, and the entries in the table are nothing but chi-square critical values denoted by chi-square alpha corresponding to given degrees of freedom and given value of alpha. So with this in mind, we try to find out some critical values for given values of alpha and degrees of freedom. Suppose alpha is 0.01 and we consider degrees of freedom nu equal to say 24, and suppose we are interested in the chi-square critical value such that area to the right side of that critical value is alpha. Suppose I am interested in this chi-square critical value, alpha is 0.01. So because alpha is 0.01, this area is 0.01, and I am interested in the chi-square critical value for alpha equal to 0.01 and degrees of freedom is 24. So in the table I will look for degrees of freedom as 24, and column headings are areas to the right side of this critical value. So I will focus on 0.01 area. So here we remember degrees of freedom 24 and alpha 0.01. So these values are for alpha. So this is corresponding to alpha equal to 0.01 and degrees of freedom are 24. So I have to go down in this column until I obtain 24 here. So I have to consider this row corresponding to degrees of freedom 24, and this is corresponding to alpha equal to 0.01. So the intersecting point is 42.980. So that is our critical value, 42.980. So this value is 42.980. We will require to find out this type of critical values. whenever we will consider hypothesis testing related to chi-square distribution. Now suppose instead of this right tail area equal to 0.01, suppose area is same, but suppose it is in left tail and we consider same degrees of freedom, say 24. But now situation is different. We are considering left tail area equal to 0.01 and suppose this is roughly probability density curve of chi-square distribution. Now here alpha is in the left tail. This area is 0.01 and because this area is 0.01, area to the right of this point is 1 minus this area, that is 0.90. So this area to the right is 0.90. So this point will be denoted by chi-square 1 minus alpha, that is chi-square 0.90. So why we are using 1 minus alpha here? Because our table is for those critical values of chi-square distribution such that area to the right of that critical value is alpha. So our chi-square distribution table gives us those critical values of chi-square distribution for which area to the right is alpha. If I have alpha here, then I can say that area to the right of this point chi-square alpha is alpha. If I am writing 1 minus alpha here, that means area to the right of this point is 1 minus alpha, that is 0.90 in this case. So for this value of alpha 0.01 and degrees of 24, I will not look for 0.01 area in the table, even though here I am taking alpha equal to 0.01, but that is area to the left side of this point and we are interested in the area to the right side of this point, which is 0.90. So in the table we will search for area 0.90 and degrees of freedom 24. That will give us this value. So now we come here again, degrees of freedom 24, and we have to search for 0.90 value of area. These are the area to the right of critical value. Therefore we are considering 0.90 here. So now I am going down unless I obtain 24. So now we can consider this row 24 and let me remove this first one, and this is the intersecting point 15.659. so chi-square critical value is 15.659. so remember, this is very important here, how to use chi-square table. In normal distribution we have symmetric curve, so we find out this critical value in the right tail and critical value in the left tail will be negative of this value if we have normal probability distribution. But chi-square distribution is not symmetric, so if you are asked to find out the chi-square critical value and if you are given the area to the left side of that value, you have to first find out the area to the right side of that value and use that value of area in the table to find out this chi-square critical value. So this is third possibility, second possibility. Now third possibility is, suppose we consider equal area in both the tails. Suppose we have alpha equal to 0.05, but we consider half of this area in both the tails and we are interested in finding the corresponding critical values. So let me sketch roughly. Again let me sketch chi-square distribution or chi-square probability curve for this Just a minute, I have to sketch again. So roughly you can show that this is your chi-square probability curve, and it will never cross x-axis, it will go parallel to x-axis. This is 0, and now we say that area in both the tails is equal, and that equal value is say 0.025. Here I consider 0.025. This area is 0.025, and this value of chi-square distribution will be denoted by chi-square 0.025 because area to the right side of this point is 0.025. Now what about this point? This point is chi-square critical value, and we don't know what is the area to the right side of this point. So that we can obtain by subtracting the area to the left side of this point. So that is going to be 1 minus 0.025, which is 0.975. Area to the left side of this point is 0.025, and we know that total area under probability density curve is always 1. So to obtain area to the right side of this point, we subtract area to the left side of this point, and that turns out to be 0.975. So now I have to obtain these two chi-square values such that area to the right side of this point is 0.025, and area to the right side of this point is 0.975. And suppose we consider degrees of freedom equal to say 50 degrees of freedom. So first I search for alpha equal to 0.025 and 50 degrees of freedom. First I am writing this critical value. So for that I have to search for 0.025 area here. So here I am, and I have to go down unless I obtain 50 degrees of freedom. So let me go down in this column, and here this row corresponds to 50 degrees of freedom. So this is the value 71.420. That value is chi-square 0.025. What is intersecting point? 71.42. So this is 71.420. Similarly, this I can decide by considering alpha equal to 0.975 and 50 degrees of freedom. So now I search under this column heading 0.975, and I have to go down for 50 degrees of freedom. So I am going down in this column unless I obtain 50 degrees of freedom. So this is corresponding to 50 degrees of freedom, and the value is 32.357. So this is nothing but 32.357. So in this way we can use chi-square distribution table, and we will require this type of chi-square critical values whenever we will discuss hypothesis testing, which is using chi-square distribution as the reference distribution. So we will again come across this type of use of chi-square table in future lectures. So I hope you have understood how to use chi-square tables. Thanks for watching.